In the world of structural design, not all timber is created equal, and knowing the difference can make or break a project. Timber strength classes provide a standardized system for categorizing wood based on its mechanical and physical properties, ensuring that each piece used in construction meets precise performance requirements. These classifications are essential tools for architects, engineers, and builders alike, enabling safe, efficient, and code-compliant timber design across a wide range of applications. Timber strength classes group timber according to its structural performance, particularly its strength and stiffness. The most commonly used system in Europe is the C classification, where the C stands for coniferous, followed by a number indicating the characteristic bending strength in newtons per square millimeter. For example, C24, which is a common timber strength class, has a characteristic bending strength of 24 newtons per square millimeter. While C classes are the most widely used in structural applications, they are not the only strength classes. The European system also includes D classes for hardwoods. In this context, the D stands for deciduous, referring to timber sourced from hardwood species. These classes, such as D24, D30, D40, D50, D60, and D70, follow a similar numbering system, where the number indicates the characteristic bending strength in newtons per square millimeter. However, it is important to note that the numbers from the C and the D classes are not directly comparable, as hardwoods and softwoods have different grading rules and mechanical properties. In addition to solid timber, engineered wood products like glue-laminated timber are also classified using strength classes, often designated with a T for tension. These T classes, such as T8, T16, or even T30, refer to the minimum characteristic tensile strength of the lamellas used in GLT. This classification allows manufacturers to optimize the performance of GLT beams by combining different strength classes within a single product. Each strength class defines several key properties that determine the performance of timber in structural applications. These include density, which is given as both characteristic and mean values in kilograms per cubic meter. Compressive strength is specified for both directions, parallel and perpendicular to the grain, just like tensile strength, which also accounts for both orientations. The bending strength indicates how well the timber can resist bending forces, while the shear strength reflects its ability to withstand sliding forces. Additionally, the elastic modulus describes the timber stiffness in different directions, and the shear modulus measures its stiffness against shearing deformation. Strength classes are determined through a process of timber grading, which can be carried out either visually or mechanically. In visual grading, trained inspectors assess the timber based on its appearance, looking for features such as knots, grain deviations, splits, and other visible characteristics that can impact the timber's strength. In machine grading, timber is evaluated using specialized equipment that measures physical properties like stiffness or density. These measurements are then used to assign the timber to a specific strength class. The assigned class reflects the timber's mechanical properties and ensures that it meets performance requirements for structural use. Strength classes are used in several key ways in construction and engineering. In structural design, engineers select a timber strength class based on the structural demands of a project, such as for beams, columns, or trusses. Building codes, including national and international standards like Eurocode 5, specify the minimum strength classes required for different applications to ensure safety and compliance. For quality assurance, timber is graded either visually or by a machine, as we mentioned before, to determine and assign it to the appropriate strength class. Strength classes matter because they ensure that timber structures can safely support the expected loads, which is crucial for safety. They also allow for the optimized use of material, helping to reduce waste and cost, thereby improving efficiency. Additionally, strength classes provide a common language for specifying and sourcing timber across different regions and suppliers, ensuring consistency. So in conclusion, the timber strength classes are fundamental to modern construction, offering a reliable framework for specifying and using timber in structural applications. By understanding and applying these classes, professionals can ensure that timber structures are both safe and efficient, meeting the rigorous demands of building standards. Stay informed, stay inspired. TimberTalk.